Carlo and Matthew. There's no me. And our project is a triple point of water.
Okay, so I'm going to talk a little bit about phase diagrams, what they are, how to read them, and what kind of information they give us, particularly within the context of the triple point of water, which is the demonstration that Carlo and I chose to do. So a phase diagram, by definition, is a graphic way to summarize the conditions under which equilibrium exists between different states of matter, which we know are solid, liquid, and gas. So a phase diagram kind of just looks like a graph with like an XY plane. So we have always temperature on the x-axis, and pressure will always be on the y-axis. And basically what a phase diagram is doing is separating the three different states of matter by three curves. So this first curve here is called the sublimation curve, which separates the solid phase here from the gas phase here, and represents the change in vapor pressure of the solid as it sublimes at different temperatures. So when a solid goes to a gas, it's called sublimation, which is why that's called the sublimation curve. And when a gas goes straight to a solid, it's called deposition. So then we will move to the next curve, which is called the melting curve right here. And the liquid phase is over here. So the melting curve separates the solid from the liquid, as you can see, and represents the change in melting point of the solid with increasing pressure. So when a solid goes to a liquid, that's called melting, and when a liquid goes to a solid, that's called freezing. And so we have one final curve called the vapor pressure curve, and it looks kind of like that. And so so the vapor pressure curve represents equilibrium between the liquid and the gas phases. And when a liquid goes to a gas, it's called vaporization, and when that gas becomes a liquid, it's called condensation. So 2 points on this graph I want to talk about. One is out here, and it's called the critical point. And the critical point is the highest temperature and pressure at which a gas and a liquid can coexist. And then the second point I want to talk about is the one that we witnessed in our demonstration that you will see in a little bit, and that is the triple point, where all three curves intersect and where all three phases coexist and are in equilibrium.
So in our demo, we created the triple point of H2O, as Matthew was explaining. And our first step was to create dry ice. So dry ice is a solid version of CO2. And so we used actually SodaStream, which releases liquid CO2 to carbonate water to create dry ice. So basically what's happening is, as the CO2 expands from its compressed form, it is released as a gas, but it performs a phase change of deposition. And because the CO2 is so cold, the gas actually freezes into a solid, giving you dry ice. Once we created the dry ice, place it in a 5 milliliter beaker full of water. What this does is it creates a gaseous form for the CO2 as it sublimes, while maintaining the liquid form of H2O. So now that the H2O is cold enough, we are actually ready to put it in the vacuum for the triple point experiment. Here it comes! So basically the CO2 is able to remain solid, which in normal temperature it would just sublime, but because it is in the vacuum, it's able to stay in a solid state at a higher temperature. And as the temperature and pressure continue to increase, it allows for both the solid and gaseous states to exist at once. And eventually the pressure and temperature reach a point where the solid also begins to melt. And so at this point is when you really see all three states at equilibrium.